today we're going to be focusing on taking the project that we built in the previous webinar and extending that a bit in order to support the pathfinding and waypoint system. Before we get into that, though, I wanted to make sure everybody's on the same page in terms of the definitions and the concepts that we're going to be using here. So pathfinding, in the simplest terms, is plotting a route between 2 points, right? And a waypoint, as we're using it, is a reference point which is used for purposes of navigation. So if you've got a map, it's easy to just say, well, I want to get from point A to point B, but there may be stuff in your way that keeps you from getting there. And so by establishing a series of waypoints, and in a GPS scenario, this might be going from one interstate to another or getting off the interstate and hitting various streets and that sort of thing. But in game development, it tends to be that you've got obstacles on your map of some sort, and you need to find a way to get around them. And there's several different ways to do that, and a waypoint system is the easiest way because you're not necessarily doing a lot of heavy calculation behind the scenes to determine the cheapest route in terms of obstacles, so much as you're just telling your bad guys or your soldiers or whoever up front that, hey, you're going to need to go this way and follow this path in order to get where you're going. And so with that out of the way, what we have here is just a very simple representation of a tile map. And so right now there's nothing on it. We've got a start point and an end point, and no terrain features or anything like that. And so clearly it wouldn't be much of a pathfinding demo if we just went straight from start to end. That would just be a straight line, and that's not really any fun. So we'll add some obstacles, and we're going to define a path that you're going to want to follow the path by hitting various waypoints to tell you, okay, go so far in this direction, and then you're going to go so far in this direction, and you're going to work your way around these obstacles to get to the end. So if we were to define our waypoints based on this, you can see we've got a series of waypoints here. We've got A, B, C, D, E, and then end. And technically, for our purposes, start is a waypoint as well because it tells our mobile unit, whether it's a good guy or a bad guy, where on the map to start. And so that's our first waypoint. And then plotting out the course becomes as simple as just listing the series of waypoints. And we're going to actually use a queue class in .NET to store each of these waypoints, and then we just have to calculate how to get there. And so what we don't want is our guy to be roaming freely around the map, lost and confused. So we're going to plot a nice path to get from each waypoint until he gets to the end. And yes, I know technically he could still go directly across the screen, but suspend your disbelief for a moment and assume there's a giant canyon or something in between the A waypoint and the end, and he's got to go around. So with this in mind, we'll go ahead and talk a little bit about the tiles we're going to use, and then we'll jump in to Visual Studio. In the previous webinar, we talked a little bit about the tiles in terms of building out our tile map. And so we've got the 4 tiles up top: water, grass, dirt, and rock, as well as a couple of what we call decals. And of course, decals do not necessarily represent terrain, but are like stickers or other objects that are placed on top of the terrain. Well, we need something to move around on the screen on our map, and so fortunately we have exactly what we need. Part of the game prototyping tiles set that we're using comes with a graphic called enemy bug, which is perfect for our purposes, and I'm not a big fan of bugs anyway, so it makes sense. So we're going to take this graphic, we're going to add it to our project, and then we're going to add some code to give him a little bit of intelligence about where he's going, add some code to move him around, make sure he behaves with the camera and everything, and we'll get that rolling. So we'll go ahead and switch over to Visual Studio at this point. Now what I've got here, I'm going to be using the same project as before, and we're just going to add on the pieces that we need to do pathfinding. If you haven't watched the previous webinar, I definitely encourage you to watch that first, because we go through the entire process of building out this project, and you may get a little lost if you don't know necessarily exactly what I'm referring to, although I will try to explain stuff as I go just to make sure, but it's definitely a good idea to check out the first one if you can. So in order to do pathfinding, we're going to need a few things. We're going to need a path, which technically we already have when we built our initial map, and we're going to need someone or something to follow it. So if we go into the Planet Cute tiles that we got from Lost Garden, we've got our enemy bug here, and I'll go ahead and drag this over, and what we're going to do is we're going to create another folder in our content project. We'll just call it Bad Guys. So we're going to add new folder, and then we're going to take our enemy bug and add him to that folder. Now up to this point, we've added tiles and decals in the past, and that's great, but they don't really do anything. So now we're adding something that can actually move around on the screen. In order to do that, though, we're going to need to add a new class to the project. And we're going to call that our Bad Guy class. Once we start adding multiple types of mobile units, you may want to extract some of the common elements out of the Bad Guy class into maybe a base class. You can call it Sprite or enemy base, something like that. But we're not going to do that in this demo. For now, we're just going to create a single bad guy, and we're going to create a class for him. So we're going to create a folder. Since if you build on top of this, you may definitely want to add some additional units besides just the one we're creating. So we're going to add a folder here, and we're going to call it Sprites. And then within that folder, we're going to add a class, and we're just going to call our class Bad Guy, because you may have sprites that are good guys. And remember, a sprite is effectively a two-dimensional graphic that gets displayed on screen. And so XNA doesn't have any concept of a sprite class in and of itself. It has the texture 2D data type, which allows you to store an image, but you're going to want to create a custom class like we're doing here in order to store additional properties and information about whatever that class represents, which in this case, of course, is our bad guy. Now, adding a class, even in an XNA project, adding a class doesn't add all of the XNA namespaces we need. So first thing I'm going to do is go ahead and add, using Microsoft XNA framework. And then we have a few fields we need to add. So we'll go ahead and open up our bad guy class here. These fields are going to keep track of stuff like how fast our enemy is going to move, where he is on the screen, and the direction he's headed. So we'll go ahead and put these in here. Velocity, in this case, this is worth pointing out, velocity is a vector 2, which gets added to the position and indicates a direction of movement rather than a speed, which of course gets tracked by the speed value here. It'll make more sense when you actually see it in action, but it's easy to confuse speed and velocity, but ultimately velocity is giving you a direction of movement as opposed to the actual speed. We're going to need a public property for the position because it's going to get manipulated from outside the class. So we'll go ahead and add that in. And of course, our bad guy is going to need a constructor. So we'll go ahead and set some initial properties when we instantiate our bad guy. We're going to set our position and our speed. Those will get passed in to the constructor. And then our velocity initially is going to be set to 0. So he's not actually moving in any particular direction. He's just there on the screen. After that, we're going to need a way to set the waypoints for our little bug. So we'll provide a method for that. We'll call that set waypoints. And so this is going to accept a queue of vector 2s, which remember a vector 2 is basically an XY coordinate So it's going to loop through this queue, and it's going to add the waypoints to our own internal queue. I think I missed a lot. Oh, I did. Hang on one moment. So I guess before I put that in, it would make sense to actually add our queue. Sorry about that. So we're adding this queue of waypoints. And so what we're going to have here is we're going to actually define waypoints as part of our tile map, but our bug needs to know where he needs to go. And so we're going to pass that queue of waypoints into our bug, and then he's going to add it to his own personal little map inside his head so he knows where he needs to go. And then this way, by making this queue part of the bug class, it means each little bug or each little enemy or each unit could have his own unique set of waypoints, which is definitely going to be preferable to trying to keep track of each individual one somewhere else, like in the tile map or whatever. So you want each bad guy to have their own set of waypoints that they need to go to, because they're not necessarily all going to go to the same place. So once we have our queue of waypoints, then we can call set waypoints from our tile map and provide the list, or rather the queue, to our bug. And then we set our position here to the first item in the queue, which is going to be our starting point. Now, in addition to this, part of our calculations are going to require that we know how far we are from a given waypoint. So we need to go ahead and add some code in for that as well. And what this will do, this will take a look at our current position, and then it'll take a look at whatever's at the top of the waypoints queue, which is going to be where we're headed, because we don't actually pull it off of the queue until we get there, right? So this takes a look at our current position and the location where we're headed, which is our waypoint, and then it's going to use the distance method off of the vector2 data type to figure out how far away we actually are. And then we'll make use of all of this by giving our little bug guy an update method of his own. So we'll go ahead and add that in. So here, what we're doing is we're going to loop through, and the first thing we're going to check and see is, do we have any waypoints left to go to? And if we do, then we're going to take a look at the waypoint. I'll get back to this if part up here. I want to talk about the bottom part first. So if we have any waypoints left and we're just cruising along on our path, then we're going to take a look at the location of the upcoming waypoint. We're going to subtract our position from it, and then we're going to normalize the vector. And so what this does, this is actually pretty neat, and I will come back to this later in the demo, but normalize takes our vector, which is going to be the difference between our current position and our destination, and it's going to reduce it to 1 unit in length, but still pointing in the same direction. So right off the bat, if you take our direction value without normalizing it, it's going to be the full distance between your current location and your destination. By normalizing it, you keep the same direction, but you reduce that vector to a value of 1, which means instead of, when it comes down to the next line here, when you actually add, or rather you multiply the direction by your speed, you want your direction to be a vector of 1 because you only want to move the amount of your speed. If you don't normalize it, then what's going to happen is you're going to multiply the full distance between yourself and the waypoint by your speed, and the result is that your bug is going to get really hyper and he's going to jump from one waypoint to the next instead of walking or crawling along the path and being nice and slow like you should be. And then once we have our position and our velocity, we're going to add the velocity to our current position. And so of course, remember, our velocity is the direction we're headed multiplied by our speed, and then we add that speed to the position, which updates our position. And then every pass through our game loop, we hit update, we hit draw. When we hit draw, we're going to draw our bug at the new position, right? And so we're updating that position in increments of our speed and we're using the normalized to make sure we're consistently headed in the right direction. So once we get, and then this part up here, once we actually get close enough to our waypoint where we're less than 1 away, then we go ahead and we grab the upcoming waypoint, set that to our position, and then take that waypoint out of the queue, at which point the next waypoint is at the top of the queue, because that's how a queue works, right? And so the next pass through the loop, of course, our waypoint will be wherever it is on the map, and our distance will be significantly more than 1, and so we'll start working our way towards that waypoint. So that's actually all we need to do for the bad guy class. But in order to support our little creepy crawly friend here, we need to make a few enhancements to the tile map class. And so I'll switch over to that. And I'll start by adding another constant to our growing collection here. It's probably worth mentioning at this point that these aren't necessary, these are necessary because of the size and shape of the source images that we're working with. They wouldn't necessarily be a part of any project that you're building. I happen to be using oddly shaped tiles, which, if you recall, I'll go ahead and pull those back up. They have a fair amount of transparency above them and in some cases below them, and this affects things like when you're trying to draw images based on the center, or you're tiling images side by side, you need to provide a little bit of overlap. And so the reason we've got all these constants is because I spent a few hours figuring out exactly where I want the images to mesh up, and in the case of stuff like our enemy bug here, because he's not centered in the image and he is actually a little bit below the center of where I would like him on the tile, then I've created these offsets that we use when we draw him to make sure he shows up in the right place. And I could crop all of our images so that they would be nice and square, but I didn't really want to mess with the source images any, and it gives a good example of how to deal with images that aren't necessarily standard. So depending on what your artist gives you, or if you create them yourself, then you may want to keep in mind that you need to specify whether or not there's transparency around them and what size they are. And of course, you definitely want them to be the same height and width overall, and just make sure that everything lines up when you're building it. Otherwise, it can be quite a pain to work with. And quite honestly, it was still quite a pain to work with just because of the non-standard placement of some of the stuff. But not a problem. So we'll go ahead and add another constant, which we're going to call our bad guy offset, because I'm original like that. So we'll add that, and then now we're going to add a variable to represent our little insectoid pest, and so we'll call that what it is. Whoops, I think I left out. I did. Left out a namespace. So using, and this is going to be our scrolling tilemap.sprites. There we go. Scroll back down, and we're going to add our bad guy, and we'll just call him bad guy. Okay. Now, we already have lists for our tile textures and our decal textures, which you can see here, tile textures, decal textures. So obviously, you can probably guess what's going to happen next. We're going to go ahead and add one for the bad guy textures. So we'll create a list of type texture 2D, because it's a two-dimensional sprite image, and we'll call it bad guy textures. New list texture 2D. All right. Now, before our nemesis can store the waypoints in his tiny little insect brain, we need to define them as part of our map. So to do that, as I mentioned before, we're going to use a queue, just like in the bad guy class. So we'll go ahead and create that. We're going to have a queue, and that's going to be full of vector 2s. Whoops. And we're going to call that waypoints. Okay, now up until now, our tile map didn't really need a constructor. But since we're going to be adding waypoints to the map, a constructor is as good a place as any to do that. The reason we didn't need a constructor before is because, honestly, our map didn't really do anything. So we could move the camera around, but we weren't actually creating anything that had any properties or mobility of its own, and so the map just kind of displayed whatever we gave it. So our constructor, though, that's where we're going to set our waypoints. And so we'll go ahead and add that in. We'll put that right up here. So you probably noticed that we've got something here called a waypoint adjustment. And the reason for that is that we're using a very simple vector 2 to represent points on the map. And so knowing that our map is basically a grid of squares, and we want to start our bug in the 3,3 position, which with the 0 base obviously is 4 squares in and 4 squares down, that's fine, but we need to translate that into an actual position in our tile map. And we can't just say stick them in this square. We need to adjust it based on the size of the individual tiles so that our draw method knows where to actually draw the bug. And so our waypoint adjustment in this case is tile width and bad guy offset. And so tile width is 101. So all of our tiles, fortunately, are consistently 101 pixels wide. And then bad guy offset is 84. And this is what we were able to figure out based on mostly trial and error, honestly, figuring out where within the sprite the transparency area stops and the bug actually starts. And so we multiply each of the position vectors, like 3, 3, 5, 3, 5, 5, by this waypoint adjustment, which gives us the actual pixel location on our big giant map. And so that's a pretty cool, easy way to do that. Then we're going to take a look. Well, we're going to instantiate our bad guy, and we're going to take a look at the waypoints queue that we've just populated here, and we're going to take the very first item on the queue using the peek method, and we're going to pass that to our bad guy as the starting point. And so you see when we instantiate our bad guy, we're passing in a position and a speed. And so the position in this case, because he hasn't moved anywhere yet, is our starting point. So we're going to set the very first waypoint as our starting point, and then we're going to pass in a speed of 0.75. And then we're going to take this queue of waypoints that we just built, and we're going to call the set waypoints method on our bad guy, which is kind of like doing a brain dump to the bug. It takes that whole queue full of waypoints and sticks it in the bug's head so that he's got a copy in memory, and so he's going to manipulate that queue separately from the tile map. The tile map will not be removing anything from the queue. It just exists to say this is the way people are going to move around on me. The queue within the bug, he will gradually remove stuff as he reaches these waypoints until there's no waypoints left. Since we're storing the bad guy textures in the tile map, we're going to need a method for adding those. So we'll go down here. We've got our add tile texture and our add decal texture. And so we'll go ahead and add a method here. We'll call it add bad guy texture. And of course, we're going to pass in a texture 2D, which we'll call texture. I'm big on being consistent. And then we'll take our bad guy textures, call the add method, and pass in the texture. Excellent. Save this. Now, we're also going to need a way for the update method in the game class to call the update method in our crunchy little pest. So we'll create an update method in the tile map that calls the update method for our bad guy and any other bad guys that we create later. So up until now, we didn't need an update method. Kind of like we didn't need a constructor because our map didn't really do anything. We actually didn't need an update method either because there was nothing to update. We would use our move camera method whenever we wanted to move stuff around on screen. So now we'll go ahead and create the update method. And we'll call badguy.update. And finally, for this class at least, we're going to need a way to draw our bad guy on screen and at the right location. And so in the previous webinar, of course, we had an area inside our draw for drawing the tiles, which was the map itself, and then drawing the decals, which were the things like the rocks and the trees that showed up on top of the map. So we're going to add another section here, and we're going to call that draw bad guy. We'll go ahead and grab a little code for that. Put that in there. And so in this case, we only have the one enemy, so this is kind of a hacky piece of code here. We're just going to grab the first texture in our bad guy textures because we know we only have the one enemy. If we were building out multiple enemies, then we would want to do this a little bit differently. So now we're going to take our it repositioned it. We're going to create a new vector 2 based on our bad guy's position minus the camera position. And so what this is doing, without this code here, you wouldn't get consistent results in terms of, let me re-highlight that. So without this piece of code here, your results would be way off in terms of where the bug actually gets drawn. And we'll come back to that after we run the demo, and I'll tweak the code a little bit and show you what actually happens. And then we'll do the same thing with the normalized method as well, because I think it's a good thing to see. So here we're taking the position of our bad guy and we're modifying it by the actual camera position so that we draw the bad guy at the right spot in relation to what part of the map we're looking at that time. And then so we pass in the adjusted position that we just created here, along with the texture for our enemy, and of course color.white, which indicates that we're not doing any funky shading on the bug. So the last thing to update, we've created our bad guy class and we've updated our tile map class. And so we need to make some updates to the game class. And there's actually not a lot to do here. Pretty much everything is contained in the bad guy class and the tile map class, so we only need to do a couple things. The first thing we need to do is we need to come to our load content, and we're going to add some code to add a bad guy texture. Just like above, we have add tile texture, add decal texture. So now we're calling the add bad guy texture. And we're going to use content.load. And we're going to pass in that it's a texture 2D we're expecting. And we're going to give it a path, which is, of course, going to be bad guys, enemy bug. And of course, we don't have to provide the extension because we're using the asset name that is provided by the content pipeline. So when we, as a refresher, when we add something to our content project, it processes it and gives it an asset name, and we can just refer directly to that asset name. We don't have to worry about the extension and stuff like that. Go ahead and finish that off. And then the other thing we need to do is in the update method for our game, we're going to add a call to update the tile map. We didn't need this before because, as I mentioned, nothing was really being updated other than the camera position, which was being handled by the move camera method. So we'll go ahead and add tilemap.update. And then at this point, if we go ahead and we can actually hit F5 and run it, jump over here. And so you can see our bug is cruising along, and our bug's a little bit OCD. He likes to always be facing in the same direction, and mostly that's just because I haven't taken the time to add code to rotate him properly based on direction. That's a fun little experiment you can try. But you can see here he's following the path, nice and neat. He goes to one waypoint, then he heads to the next waypoint. If we set waypoints that didn't line up with the corners of our path, he would go to those. But in this particular case, each corner represents a waypoint. And so he's just going to keep going along, backwards or forwards, to each waypoint on the map. And you'll notice, as we move the map, it's still drawing our bug in the right place. He's not moving independently of the map, which is a big deal, because otherwise it would look really, really strange. Okay, so we'll go ahead and kill that for now. Where did my stop button? Here it is. So we'll kill that. And then there's a couple things I wanted to revisit now that everything's up and running properly. And so the first of those we talked about was the normalized method. So if we go back to the update method in our bad guy class, and we comment out this line, and then we go ahead and run it again. You got to watch quick, because the bug is moving a lot faster this time around. I didn't hit a 5. Let me try that again. There we go. So watch what happens. The bug basically bounces, and that was fast. Let me do that again. The bug bounces from one corner to the next, because he's not actually walking or crawling to each waypoint. He's taking the full distance from one waypoint to the next as his movement, and we're not actually normalizing it down. And so instead of moving at 0.75 per frame, he's moving the full distance per frame, roughly. And so we'll go ahead and run that again. And if you watch, see, there he goes. He is on the move. The problem with this, of course, is that it doesn't really work in some scenarios. And so if you've got a game where you want pathfinding to be, or waypoints to be used for troop movement, then unless they're teleporters, it doesn't really make sense for them to move that way. So that's why we normalize. But there are cases where this technique could actually be handy to not normalize. And so maybe maybe you have a need in your game for something to appear at various points along a path, whether it's a series of lights or some type of enemy that literally bounces from one spot to the next over and over, and you've got to hit it when he's in the right spot. Then not normalizing becomes very useful, because you can set a series of waypoints, and instead of having your guy move slowly from one to the next, your guy or your lights or your targets or whatever can light up in a series, but not going gradually from one to the next, but just literally lighting up one after the other in series. So there's a number of different ways you could actually use that. So the other thing I wanted to revisit is drawing the bug without actually applying the camera position. And so for this one, go ahead and save this. If we go to the draw method of our tile map, we've got this stuff here, and I'm going to go ahead and remove this part of it. There we go. And we will rerun it. And it's gonna go quick, so be sure to watch carefully. When our bug loads up, you can see we're moving the map, and he's not actually following the path at all. And in fact, once he's gone off the screen, we can't even catch up with him, because he's following the path in his head, right? So he's still got his set of waypoints that he has to get to, and he's going to follow that path. But in this case, it takes him out of our camera view, because he's not respecting the map. He's just following, okay, I need to go so many pixels straight and then so many pixels down. And it doesn't matter where on the map we're looking, he's just moving. And so he could be moving through rocks or walls or whatever. So by using the camera position as part of our draw, we'll go ahead and add that back in, and then we rerun it. This tells XNA to draw him at the right spot, and as we move our map around, it still draws him in the right position relative to the map. We'll go ahead and exit that. And that is a very simple introduction to using waypoints as part of pathfinding. So we'll go back here, and here's a screenshot of our little bug making his way along the path. And then if you guys have any questions, I'm here to answer them, and we can dig into any other parts of the code that we need to. Looks like we have one question already. Did you ever post the code? I assume that's in reference to the previous webinar, and my apologies, I have not, but I will make sure to get that up there today, and it'll be in my blog, which is www.blogusmaximus.net, and the very top entry in that blog lists all of the webinars along with links to each of the ones that I've already done, and registration links for the upcoming ones, and they'll also have the code there that you can download. See if we have any other questions.
Hey Chris, while we wait for questions, so what are you have 2 webinars left on Windows Phone 7. What are you covering next week?
So next week we're going to take a look at the Microsoft push notification service, and we'll do examples for that with Silverlight and XNA. And so I touched on that a little bit in the first couple of webinars, just explaining the different types of push notifications, but we didn't actually use any of them. So we'll be digging in deeper on that, showing how to use the various types of push notifications, and along with code samples, like I said, for XNA and Silverlight. And then the talk after that in 2 weeks is on using the Microsoft Ad SDK with your apps or games. And so this is a way, maybe you don't want to charge for your app, but you want to still make money off of it. And so you can publish a free app and then use advertising to get a little bit of revenue from your app or game. And so we'll go through how to add, well, how to add ads to your app or game, both in Silverlight and XNA, and how to set up your account in the Pub Center as well, so that you get all the right codes and everything that you need to point your application to show the right ads, and you can break them down by category and interest, and even by geographical location, and we'll go through all of that as well. Looks like we have a question here. Do you know of any smart algorithms that query the exact location of the player character and adapt the enemy locations whilst being lightweight? Well, there are a number of different techniques you could use for something like that. Typically, what you're going to do is you can do a combination of waypoints. So your enemy is going to progress towards a certain area, but then if you are within a certain area, then you can adjust their course to head towards you. There are also algorithms like A* that look at pretty much the entire map, or at least the map within a given area, and they don't rely on waypoints, but instead they evaluate every square on the map around them, and then they pick based on concepts like terrain difficulty or obstacles. They pick the least expensive route to get somewhere. So in this case, your player character would be their destination, and their current location would be their starting position, and they would look at each tile, and if a tile contains a wall, then it's impassable, and so that's too expensive to move through. And if a tile contains muddy terrain and a clear path terrain, then you would have to code it this way, but the muddy terrain, of course, would have a more expensive movement cost than the path, and so you would be able to calculate the cheapest route by following the path to the player. And as the player moves, then that algorithm is going to get updated. So each time you go through the update loop, you're effectively recalculating your path. And so obviously your player can only move so fast. And so for the most part, you're not going to change your overall path, but it could introduce potential where maybe your character enters a building, and so the soldier unit or the enemy unit has to recalculate in order to get to the right side of the building. And so a little bit of intelligence in the code is required there, such as knowing, okay, I can only enter this building from a specific side, and you don't just keep running into the back wall or whatever. But A* would be definitely a good one to look at as far as calculating path towards a moving target. Will you do anything for ads monetization outside the U.S.? No, actually, I won't be covering anything specific about other countries. This will be generic to basically whatever countries are supported by the advertising SDK, and that's something that Microsoft decides.
All right, Chris, well, that looks like all the questions.
All right.
For this webinar.
Oh, wait.
Just kidding.
What about difficulty levels? Should it be done in the player finding algorithm or somewhere else? So typically difficulty levels could be handled in a number of different ways. It may be a function of the actual level itself. So one thing we didn't really cover that much in the previous webinar was the ability to have, of course, multiple levels in your game. And so maybe level 1 has one map and level 2 has a completely different map. And along with defining the tile map and defining the waypoints on that map, perhaps the difficulty would be a function of the tile map level as well. And so you could use it to do things like you could make it a multiple that increases the speed of the bad guys, or you could use it as a multiple that maybe increases the firepower of the bad guys. Or depending on the type of game you're making, if you're doing something like a tower defense game where you've got a fixed path and you've got a start point and an end point, and you're building up a bunch of defenses to, of course, kill off the encroaching army, then typically the way difficulty gets handled there is each wave is a little faster and a little tougher than the one before it. And so in that case, you would probably have some type of wave manager class that keeps track of which wave you're in and actually spawns the various enemy units and then sets the properties as they're being created so that while they wouldn't necessarily get faster within the wave, one wave to the next would be, say, 10% faster or 10% tougher and that sort of thing. In an RPG, difficulty levels would probably be on a more global scale. So you wouldn't necessarily have difficulty from one combat to the next. You could have your entire game, say, be easy, medium, hard, nightmare, that sort of thing. Or if you're talking levels more in the sense of character progression levels, like you have a level 6 fighter, then in a case like that, I would probably have certain areas of the world present harder challenges, which is kind of the MMO approach as well, right? So in games like World of Warcraft, typically you've got the newbie areas that have a bunch of low-level monsters, and then once you venture out of there, you can explore gradually tougher and tougher areas, and which present greater challenges. And of course, if you haven't leveled your own character up and you go into a high-level area, you're going to get stomped. And if you are a high-level guy taking on little newbie monsters, then you aren't going to really receive the full benefit, maybe in terms of experience or treasure or whatever that you need in order to keep progressing. So a lot of it's a balancing act, and it's kind of up to the individual developer how to implement something like that. Is all of this covered in my book? Well, that's actually a good question. So the scrolling tile map stuff is not. This is some stuff that I put together after publishing the book, but definitely check out the previous webinar as well as this one, and if you have any questions, feel free to shoot me an email, and Let me go ahead and get that up there. So you can reach me at my Gmail or via my blog or even on Twitter. Chris, can you offer an example of path following, such as an orbit or nonlinear path? That's probably out of the scope of the Q&A for today, but there are definitely some good examples out on the web. Let's see. After watching you code this webinar, I feel like I need to go back to uni. University? Is that what you mean? I'm not sure if that's good or bad. Hopefully it was clear and easy to follow. And like I said, if I wasn't clear on something, or if you just need maybe to bounce a few ideas off of me, feel free to drop me an email, and I'll be happy to help you out.
Thank you so much, Chris. All right, everybody. So like Chris said, his final 2 webinars on Windows Phone 7 are coming up July 14th, using the push notification service in your apps or games, and July 21st, making money from free apps with the Microsoft Ad SDK. You can register for them and all of our upcoming webinars currently posted through August. Check them out and register at devexpress.com/webinars. Our final webinar this week, tomorrow at 10 a.m. Pacific Standard Time, towards code correctness, integrating software contracts and unit testing with Dino Esposito of iDesign. This webinar shows you why you should look seriously at software contracts or code contracts in the .NET jargon, and what's the appropriate angle and perspective for that. And again, if you missed anything from this webinar or want to review any of our previous webinars or check out hundreds of online product tutorials, you can visit us on the DevExpress channel at tv.devexpress.com. Again, thanks so much to Chris. Thank you all for joining us, and thanks for choosing DevExpress.